Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through, continuing through chapter 8.4, and we're going to be discussing Maclurin Polynomials, so let's jump right in. So, what is a Maclurin polynomial? It's something we can use to estimate the value of a function at a certain point. So let's do a simple function, like e to the x. Well, what the Maclaurin, actually, let's not do this. What a Maclurin polynomial says is that the polynomial that will best estimate our function at a certain point, in this case, we're approximating the function in the interval between -1 and 1, whose center is, of course, x is 0. We can approximate this as f of 0 plus f prime of 0 over 1 factorial times x plus f double prime, so the second derivative of f at 0 over 2 factorial times x squared, plus the third derivative of 0 over 3 factorial times x cubed, and so on, for how much we want to estimate it by. So yeah, this is quite important, as it allows us to estimate functions. Otherwise, how do we calculate something like e to the x? It's very hard, if not impossible. And so we can sum this up as p of x is equal to the sum between x equals 0 to n, where n is the degree that we want to approximate it to, of f to the n of 0 over k factorial, f to the k of 0 over k factorial times x to the k. So we can approximate it using this. So let's jump right into some questions which ask us to approximate some expressions using this polynomial expansion. So the first expression we need to do is f of x is equal to x times e to the x. So we need to approximate this as a polynomial to the fourth order. So that would be to x to the power of 4, I believe. So how do we approximate this? First of all, we need to get f of 0, and f of 0 will be equal to, well, 0, since this is 0 times e to the 0 is 0. Next, let's get the first derivative of f. So we get the first derivative is equal to, using product rule, this is x e to the x plus e to the x. And so if we get the value of this derivative at 0, this will be equal to 1. Next, if we get the second derivative of x, this is equal to x e to the x again, plus 2e to the x. And so the second derivative at 0 is equal to 2. Next, we have the third derivative, which is equal to x e to the x plus, well, 3e to the x. There's a pattern here. And so we get f of the third derivative is equal to 3. What order do we need to approximate this to? 4, I think. So we need to do the final fourth derivative of f, or f of 4 at this point, which is equal to x e to the x plus 4 e to the x. So f of 4, the fourth derivative at 0 is equal to 4. So now we can make a polynomial. So, because we have each of the derivatives, and so we know this polynomial will be in the form f of 0 plus f prime of 0 over 1 factorial times x plus f double prime of 0 over 2 factorial times x squared, and so on. Let's just write out this full expansion. Okay, f of 0, f prime, f double prime, plus f triple prime of 0 over 3 factorial, x cubed, finally plus f to the 4 of 0 over 4 factorial times x to the 4. So what does this evaluate to? We can simply plug in the numbers we have here. So this is 0 plus 1 over 1 factorial, which is just x, plus 2 over 2 factorial, which is just x squared, is 1, plus 3 over 3 factorial, which is 1/2. So we have 1/2 x cubed plus 4 over 4 factorial, which is 1 over 3 times 2, which is 1 over 6. X to the 4. So this is the Maclaurin expansion, or polynomial, to the 4th degree for x e to the x. So if we plug this in, this should approximate the function x e to the x pretty accurately. So if we want to confirm this graphically, let's look at Desmos. So we have here x e to the x, and then over here we have, what is this, x plus x squared plus 1/2 x cubed plus 1/6 x to the 4. And so as you can see, it approximates this function pretty accurately for the interval that we were given. So yeah, that's pretty nice. I mean, the interval's around 1 and 1 over here, and as you can see, it approximates it quite nicely. Next, let's do the next function. And the next function is we need to approximate sine x. So f of x is equal to sine x. Okay, so f of 0 will of course be equal to 0, and then we get the first derivative, which is equal to cosine x. So the first derivative at 0 will be equal to 1, and then we get the second derivative at 0, which is equal to negative sine x. And so the second derivative at 0 will be equal to 0. Next, the third derivative of x is equal to negative cosine x. And so the third derivative at 0 will be equal to negative 1. And finally, we have the fourth derivative of x, which is equal to sine x again. And so the fourth derivative at 0 will be equal to 0. So now let's plug these numbers into the expansion. So we have 0 plus 1 times x, so that's x, plus 0 over 2 factorial x squared. So we can skip that term. Plus minus 1 over 3 factorial x cubed, plus, and then so on, since we only need to really consider the terms of x and x cubed. So this will be equal to x minus 1/6 x cubed as our approximation for this function. And let's look at this graphically. We have sine x, and we have x minus 1/6 x cubed. Oh, is x cubed is the bottom? No, that's not correct. 1/6 times x cubed. And as you can see, it approximates it quite nicely for the interval between 1 and negative 1. And of course, if we add more terms, like if we add plus 1 over 120 x to the 5, this gets more and more accurate to the actual curve. Next, we have the function f of x is equal to 1 minus x to the negative 1. So f of 0 at this point will be equal to 1. And so let's get the 4 derivatives. So f of x is equal to f prime is equal to, just open this, make it run a bit faster. Anyways, f prime will be equal to 1 minus x to negative 2, since we multiply by negative 1, and the derivative of this is negative 1, so negative 1 times negative 1 is just 1. So f prime of 0 is equal to 1 to the negative 2 is 1. Next, f double prime x will be equal to 2 times 1 minus x to the negative 3. So f of 0 in this case will be equal to 2. Next, f triple prime will be equal to 6 times 1 minus x to the negative 4. So f of 0 will be equal to 6. And finally, f of 4 of x, sorry, you can't see that. F of 4, the fourth derivative, will be equal to 24 times 1 minus x to the negative 5. So the f of 0 will be equal to 24. So finally, if we take these terms, we have 1, 1, 2, 6, 24. So this should be equal to 1. plus 1 over 1 factorial x plus 2 over 2 factorial x squared plus 6 over 3 factorial x cubed plus 24 over 4 factorial x to the 4. And if you evaluate this, you simply get 1 plus x squared plus x cubed plus x to the 4. So let's look at this graphically, see how well the two methods are. So if we have the graph of 1 over 1 plus x, 1 minus x, I think. So 1 minus x. 1 minus x, then minus 1, yep. And so we have the other graph of 1 plus x squared plus x cubed plus x to the 4. As you can see, it approximates it like relatively okay, x to the origin. If we were to keep on going, plus x to the 5 plus x to the 6 plus x to the 7, as you can see, it gets closer and closer to approximating our function. So this is a reasonable approximation. Sorry about that. The next question is f of x is equal to x times 1 plus x squared to the negative 1. So this is probably an easier way of rewriting it. F of 0 is of course going to be equal to 0. And so we need to first get the first derivative. So f prime will be equal to 1 plus x squared to the minus 1 minus 2x squared times 1 plus x squared to the negative 2. Yeah. So f of 0 will be equal to, well, this is 0 and this part will be 1, so f of 0 is equal to 1. Next, f double prime of x is equal to negative 1 plus negative 2x times 1 plus x squared to the negative 2. What do you have here? Minus 4x times 1 plus x squared to the negative 2 plus 8x times this is 8x cubed, no, 8x to the 4, no, 8x cubed times 1 plus x squared to the negative 3. So since all of these have a term in x, then f double prime of 0 will be equal to 0 again, since these terms will all be equal to 0. Next, for the third expansion, this will be equal to, and there's a bit of a hint, because all of these terms really past this first term won't matter since they all have coefficients in x, and they're not really going to be removed anytime soon, at least for until the fourth derivative, so we can just focus on this term here. So this term here is equal to derivative of this, negative 2 times 1 plus x squared. Oh wait, no, this one will actually matter. I mean, this higher order derivative won't matter, but this one will actually. Minus 4x. So this is minus 2 times 1 plus x squared to the power of negative 2 plus 4 plus 8 x squared times 1 plus x squared to the negative 3 minus 4 times 1 plus x squared to the negative 2, and then so on. So this is simply equal, because all of these other terms will have an x in them, so f triple prime of 0 will simply be equal to 2 minus 4, I think. Sorry, minus 2 I guess it's just x over 6. Minus 6. So this will be equal to minus 6 because it's minus 2 times minus 4. And then for the fourth one, we can go through it, yeah, I guess, but straight away we can tell, of course, here, well, we need to derive the inside term, so this will produce no term without x in it. The same for this case. And then when we derive this is x squared at the very least, so this will be equal to 0. So f of 4, the fourth derivative at 0 will be equal to 0. So this final sequence will be equal to 0, 1, 0, 6, negative 6, 0. So this is x plus negative 6 over 3 factorial times x cubed, which is equal to x minus x cubed. So if we were to approximate this x over 1 plus x squared, we can try x minus x cubed, which gives us a relatively good approximation for this area. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.